When I started trigonometry, I was traumatized by radians. To me, I kept thinking them in terms of degree, so it would give me comfort to convert them to degrees. But from a first principles perspective, radians are actually more intuitive. Degrees are kind of arbitrary. They've been passed down for millennia due to certain mathematical systems invented by ancient civilizations, but the numbers are actually arbitrary. Radians, on the other hand, are not arbitrary. And as you get higher and higher into math, you'll be able to use radians to do more things. So let's start out strong. Let's explain radians. So here we go. To understand radians, this is the formula. Theta, you can think of it as the angle, but in this case, we're not going to think degrees. We're just going to use radians. S is the arc length, aka the length of whatever portion of a circle. And the R is the radius. So it's inherently just a ratio. What is the ratio of the arc length to the radius? Another way to think about it is how many radii are in the arc length. Now that we understand this, imagine we had a radius. So imagine we had a whole circle. So this is the center, and the radius is 1, and you take the same length and you wrap it around the circle, so the arc length is 1. 1 divided by 1 is 1. So that is 1 radian. 1 radian is when the arc length is the same length as the radius. That's a radian. So inherently now, you sort of have a visual way of thinking about what a radian is. And from here, this is where the magic comes from. And this is also a trap that students fall in that we're going to clarify now. So you don't say this after many years of studying trigonometry and you forget and you're like, oops, I didn't understand the fundamentals. So what is the circumference of a circle? Well, if you remember geometry, actually before geometry, from basic arithmetic, you remember it's the diameter times the pi. Now, pi is a constant. The diameter is double the radius. So sometimes you can write it as 2 pi r. Sometimes you can write it as 2r pi. But since it's all multiplication, you can switch the numbers around. It's all good as long as you multiply them all. So this is the formula for a circle. Now we take this ratio and let's multiply the r over to get the arc length. Since before we knew that the theta, aka the angle of the radian, was the arc length divided by the radius, now we know that the theta of the angle, aka the radian, times the radius is the arc length. Now, here's a question I have for you guys. What would the arc length be if it were the entire circle? Well, the arc length would be the circumference of the circle. So if we set the arc length and the circumference of the circle equal, we can substitute the formula for the circumference of the circle on the side that says circumference, and then we can substitute the formula for the arc length on the other side with the s. Now, we divide by the r's to get rid of the r's, and look at this. The entire circle, the radians of the entire circle is 2 pi radians. Notice I wrote this very, very, very clearly. It's not 2 pi, it's 2 pi radians. There's a unit involved. So what is half a circle then? Half a circle is pi radians, right? You divide this by 2, so pi radians. That's the key. You have to have a unit to this. So now let's have some fun. We know that a full circle is 2 pi radians. Well, half a circle we already saw was pi radians. What about a quarter of a circle? A quarter of a circle is pi over 2 radians. How about an eighth of a circle? An eighth of a circle is pi over 4 radians, etc., etc. We can break it down, we can chop it, etc. But now that we inherently understand how we derive these values for the radians, of course, we can try to convert it to the 360-degree arbitrariness and be like, oh, well, pi over 4 radians is this amount of degrees, and pi over 2 radians is this amount of degrees, etc., etc. Or we can just work with radians and just picture it this way. Now, obviously, if you're learning in high school trigonometry, you're going to probably have to do certain problem sets on tests and stuff like that to convert it back and forth. So you still have to learn how to convert it to degrees. But I hope what I showed you is you don't inherently have to go from degrees to radians. You can directly work in radians and understand it intuitively. And from this, you can work the unit circle. We can build on this and we can start learning trigonometry the correct way, which is in radians. Let me take that back. There's no correct way, but this is probably a more effective way to think in radians, not be intimidated by radians, and be able to picture radians on top of that. Hope you guys enjoyed. A lot more to come.